Okay, so last class we talked about solving systems of equations by graphing. Now we're going to talk about the other two methods, and that's by solving by substitution and solving by elimination. So once you know all three of these methods, you can choose any method to use to solve a system of linear equations unless specified otherwise. So if it says specifically solve by substitution, then you are required to solve by substitution. So the difference between substitution and elimination is in substitution, we're going to be trying to get a variable by itself in one equation and then plugging in that equation into the other equation. So we're going to be solving for x and y. So for example, in number 1, looking at the two equations, which equation would be easiest to get any variable by itself, the top or the bottom? The bottom one. And again, we can get any variable by itself. So I'm going to go ahead in that bottom equation. I am going to add y over, so I have an equation in terms of x. So if I do that, I have x is equal to y plus 4. All I did was move the y over to the other side.
Why did you say you did that? I'm sorry, I was writing it down.
So in substitution, our goal is to get one equation where we have a variable by itself.
Okay.
And it doesn't matter if we get the x by itself or the y by itself, whichever is easiest. So in this case, it was easiest to get the x by itself because all we had to do was add the y over. Once we have an equation in terms of one variable, we are going to substitute x equals y plus 4 everywhere we see an x in the top equation. So we're going to take this y plus 4 and we are going to be plugging it in for this x value. So that means we have 2 times y plus 4, that's what we plugged in, plus 3y equals 8. And see, the reason we did that is now we have an equation all in terms of one variable, and that variable is y. Now we just solve this equation out for y, and we'll get our first answer. So I'm going to distribute the 2, and I get 2y plus 8, and then bring down that plus 3y equals 8. Then I combine like terms, so I have 2y and 3y, which becomes 5y. Bring down the plus 8 equals 8. Okay. Then I'm going to subtract 8 to the other side, and I get 5y is equal to 0. So that tells me y is equal to what number? 0, because when I divide by 5, anything that 0 is being divided by is 0. So that's my first answer. How do you think I'm going to find my second answer? Good. I can plug in 0 into any of these equations for y. So it looks like the easiest one to do is that one that I highlighted, that x minus y equals 4. So I have x minus y equals 4, which was one of my original equations. We found that y is equal to 0, so I'm going to have x minus 0 equals 4. Do we need that minus 0 there? Nope, so this is just x equals 4. So if I was to write my answer as a point, this would be what point? Close. Remember, it's x comma y. 4 comma 0. And that is my answer. So I need to see the answers for what you get for both x and y. And then your final answer is written as a point. And this is the same thing we would have found if we would have took these two equations, put it in y equals mxb format, and graphed them, and we would see that they would intersect at 4 comma 0, meaning they have one solution. Okay. Any questions on the steps? Yes.
So when you're getting your variable by itself, for the equation like that you're gonna put it into, is it going to be the opposite? So like you're gonna get the opposite answer. So with the x, you get the y, and then you find for the x at the end.
Correct. Correct. So if I get y by itself, then ultimately I'm finding the x value. Yeah. Okay. So looking at number 2, we have 4x minus 2y equals 6 and 2x minus y equals 1. We're still using substitution, so we have to determine which equation would be the easiest to get a variable by itself. And which one would that be, top or bottom? Good, bottom. And which variable is easiest to get by itself? Y. So that's what we're going to do. Okay, so we're going to get y by itself. So I have 2x minus y equals 1. I'm going to have to subtract the 2x over. And I have negative y is equal to negative 2x plus 1. And I don't want a negative y, so what's going to happen to all my signs?
Flip them.
Yep, it's going to change. So now I have y is equal to positive 2x minus 1. Okay. This 2x minus 1 is where I'm going to be plugging in into which equation, top or bottom? Top, because I already used the bottom one to get the variable by itself, so I have to plug it into the top one. So I am plugging it into this y value here. So that means I have 4x minus 2 times 2x minus 1, because that's our y value, equals 6. Okay. Notice how this equation is now all in terms of x. So we are going to be solving for x here. So we need to first do what? Distribute the 2 or the negative 2? Good, the negative 2. So I have 4x, and then negative 2 times 2x is negative 4x. Negative 2 times negative 1 is positive 2, is equal to 6. What happens to the x's here? Good, they cancel out. So that means we are left with 2 equals 6. Is that a true or false statement? It's a false statement. So since I got a false statement here, what type of solution is this? No solution. What if I got a true statement?
Infinitely many.
Infinitely many. Good.
What do you mean a true solution? I'm sorry.
So, like, what if I got 2 equals 2?
Okay.
Then that would be true, so then it would be infinitely many. So in this one, we didn't have to completely solve, because we found out right away it has no solution. So since it has no solution, this tells us what? What would our graph look like? No, not no slope.
Parallel.
Parallel lines. Parallel lines. Okay, so if you were to graph those two equations, you would have 2 parallel lines. Number 3, we have 3x plus y equals 9, and 2x minus y equals 2. So again, using the substitution method, we have to pick which equation we believe personally, because you can choose any equation you want. Which equation we think it'd be easiest to get a variable by itself. So what do you guys think, top or bottom? Okay, so bottom would work, and what variable would we get by itself? Y. Okay. Notice that we could also have used the top equation. We could have gotten y by itself in the top one as well. but it doesn't matter which one we use as long as we're getting a variable by itself. Okay, so I have 2x minus y equals 2. I need to get y by itself, so I'm going to subtract 2x over. And I have negative y is equal to negative 2x plus 2. And what is my answer going to be? Because I don't want that negative in the front. Good, flip the sign. So now I have a positive y equals positive 2x minus 2. So where am I plugging in this 2x minus 2? Into the y in the top equation. So that means I have 3x plus 2x minus 2 equals 9. Anytime I plug anything in, I'm always going to plug it in with parentheses just in case. But in this case, do we need those parentheses? No. So I'm just going to go ahead and erase them. Okay, we always plug it in with parentheses just in case. But in this case, we didn't need anything because there was nothing in front of that y. So from here, we're going to have to combine like terms. So what are the like terms we have on the left side?
3 and 2.
3x and 2x gives us 5x. Bring down the minus 2, bring down the 9. Then what are we going to do?
Add 2.
Add 2, so we have 5x is equal to 11. And then when we divide by 5, we get x is equal to 11/5. Okay, try to keep it as a fraction for as long as possible. Okay. So that means we are plugging in that x equals 11/5 into which equation?
Y equals 2x minus 2.
Good, we could plug it into this equation because this is where we got y by itself. That would be the easiest because y is already by itself. Or we could plug it into either of these two top ones. It doesn't matter. As long as you're plugging it into either an original equation or when you got your variable by itself. Either way, you're going to get the same answer. So I'm going to go ahead and plug it into that y equals 2x minus 2. Our x was 11/5, so y is equal to 2 times 11/5 minus 2. What is 2 times 11/5?
21 over 5.
Good. Well, close. 22 over 5. Because this 2 is over 1. So if we multiply 2 times 11, we get 22. 1 times 5, we get 5. Then we're going to subtract 2, which I'm going to write as 2 over 1. So that means we need to find a what? Common denominator. And what would that be?
5.
5. So what do we have to do to that second fraction?
Multiply by 5.
Good. Just the top or both? Top and bottom?
Oh, top and bottom.
Top and bottom, we're multiplying by 5. So if I rewrite this equation, I have 22 over 5 minus 10 over 5. Okay, because 2 times 5 gave us 10, 1 times 5 gave us 5. And what's 22 minus 10? 12. So my answer for y is 12/5. And if I have to write this as a point, my point would be
11/5, comma 12/5.
good. 11/5, comma 12/5. Remember, if I have a solution, meaning I have both x and y, I have to write my final answer as a point.
So that point would be like one solution at that point.
Correct. So it would look like a graph that crosses at that point, 11/5, comma 12/5. And if we were plotting this point, that is when we would turn that into a decimal, okay? But since we're not going to be graphing when we're doing substitution or elimination, we can leave it as a fraction.
Question, that x equals 11/5, if I had wanted to plug that into like, say, 3x plus y equals 9, would I have gotten my answer?
Correct. Yep, no matter which equation you plug it into, either these top two or when you got the variable by itself, you'll always get the same answer.
Okay.
It's just easier to plug it into this one because we already have our y
It's
equals.
already done.
Yeah. Okay, any other questions? Okay, sometimes we'll have equations like this where it's not necessarily obvious which equation we can use to get a variable by itself. Okay. So in this case, we would just pick either equation because it looks like it's going to require some steps for both x and y, no matter which equation we use. So which one do you guys want to use, top or bottom?
Top.
Okay, we'll use top.
That's
And
not
do,
negative.
and do you want to get x by itself or y by itself? Okay, let's get x by itself. So I'm going to say x by itself, so I know what I'm doing. And then I have my equation 2x plus 3y equals 10. Since I want x by itself, what would be my first step? Good, so I would subtract 3y over, so I have 2x equals negative 3y plus 10. And then what? Good, so divide everything by 2. And I get x is equal to negative 3/2 y plus 5. Okay. So that means I'm going to take that negative 3/2 y plus 5 and plug it in where? In the bottom equation, and for which variable? X, because I got x equals. Okay, so that means I have 4 times that negative 3/2 y plus 5 minus 6y equals 8. So now I plugged in the equation that I found for x into the x variable of the second equation. So now I have an equation entirely of just y. So now I need to solve for y, and what would be my first step to do that?
Put 4 over 1 and cross multiply.
That would be for the first step, but what's this step called?
Oh, distribute.
Distribute. So I'm going to distribute that 4, and for the first step, I would have to do 4 over 1 times negative 3 over 2, and that would give me what?
Negative 12 over 2.
Good, negative 12 over 2, which could reduce to what? Negative 6. So this is negative 6y. And then I have 4 times 5, 20. And then I bring down my negative 6y equals 8. So just to note here, what we did is we crossed and multiplied. So 12 over 2, which reduces to negative 6. Now we combine like terms, so what is negative 6y plus negative 6y? Negative 12y plus 20 equals 8. And then if I subtract 20 over, I get negative 12y equals, what's 8 minus 20? Negative 12. So if I divide both sides by negative 12, I get y is equal to 1. Once we have our y value, we can plug it into any equation we want. Do we want to try one of these top ones, or do we want to just plug it into this one?
Let's do the top one.
One of the top ones? Okay, let's go ahead and plug it into that highlighted one, that 2x plus 3y equals 10. Okay, so 2x plus 3y equals 10. We found that y is 1, so we have 2x plus 3 times 1 equals 10. So I have 2x plus 3, because 3 times 1 is 3, equals 10. What would be my next step? Subtract 3, so I have 2x equals 7. And then what's my last step? Divide by 2, so I had x equal to 7 halves. And we would have got the same thing if we would have plugged into this equation here. Or this equation here. Okay. So that means I have one solution at what point?
7 halves, comma 1.
Good, 7 halves, comma 1. Okay, any
In reality,
any questions?
7 halves and decimal mark up to 3.5, right?
Yes.
yeah, it's just it's substitution.
Okay.
Because we're not doing these fractions.
Okay, remember we're still doing substitution. So that means we need to get a variable by itself. And these equations, again, it's not so obvious which one we could use. So which one do you want to use, top or bottom? Top, and then what variable do you want to get by itself? Y, okay. So y by itself, and again, you can choose either equation and you can choose either variable, okay? So I have 3x minus 2y equals 7. We said we're getting y by itself, so first I have to move over my x's. So I have negative 2y is equal to negative 3x plus 7. And then I want to get rid of that negative 2 in front of the y, so what am I going to do to the whole equation? Divided by 2 or divided by negative 2? Yeah, because I want that whole thing gone in front of y. So divide everything by negative 2, and we get y is equal to 3 halves x minus 7 halves. Okay. So that means I'm plugging in that 3 halves x minus 7 halves into which equation, top or bottom? Bottom, yeah, because we always use the opposite equation. So if we're getting a variable by itself in one equation, we have to use the opposite when we're plugging in. So we're going to be plugging in that in for y. So I have 6x minus 4. Plugging in that 3 halves x minus 7 halves in for y equals 14. Now that we have our equation all in terms of x, what are we going to do first? Good, distribute that negative 4. So I'm bringing down that 6x. What would negative 4, and let's write it over 1, times 3 over 2 give us? Negative 12 over 2. Can that reduce? To negative 6. So now we have negative 6x. Okay, what about negative 4 over 1 times negative 7 over 2?
Negative 14?
So just focusing on the fraction first,
Oh.
we would get a negative times a negative, so that's a positive, right? 4 times 7 is 28, and then 1 times 2, 2. So what's 28 divided by 2? 14. So plus 14 is equal to 14. Okay. So for this one, we are going to combine like terms. So what's 6x minus 6x? What happens here? They cancel, and we're left with 14 equals 14. Is that true or false? True. So what's our answer? infinitely many solutions. So that tells me if I was to graph these two equations, how would the graph look like?
On top of each other.
Good, it would be two lines on top of each other, meaning they cross at infinitely many points. Once you get something like a true or false statement and you get no solution or infinitely many, you're done. You don't have to continue plugging anything in because there's nothing to plug in.
True.
Okay. Okay, number 6, we're still doing substitution here. So which equation, top or bottom, do we want to get a variable by itself? Bottom. And which variable? The y, because notice there's nothing in front of that y. So this one's very easy to get y by itself. So I'm getting y by itself. So I have negative 3x plus y is equal to negative 5. What's the only thing I need to do here? Add 3x. So I have y is equal to 3x minus 5. And we would be plugging in that 3x minus 5 into what equation? The top. And for what variable? Y. So right here. Okay. So I have 5x plus 2 times 3x minus 5, because that's my y value, equals 12. So now I have an equation entirely made of x. So what's my first step? Distribute. So I have 5x, and then what's 2 times 3x? And then 2 times negative 5? Good, equals 12. Combining like terms on the left side, I have what? 11x, and then minus 10 equals 12. What's my next step? Add 10, so I have 11x equals 22. And then last step, divide by 11. And what's 22 divided by 11? 2. Okay. And where would I plug in that 2 to find my y value? Good, so any of these ones, or where we got y by itself. Which one's easier? The y by itself. So I have y is equal to 3, plugging in that 2 for x, minus 5. So that means I have y is equal to 3 times 2 is minus 5, so y is 1. And that means I have one solution at what point? 2, 1. Okay. Let me see how many more I have for.
So truthfully, after we find one of the variables, we have 3 different choices that we could choose from
Yes.
to plug in that y,
Yes.
or that x, sorry, or vice versa.
Yeah, whatever variable, and you'll always get the same answer no matter which one you plug it into. Okay.
I know I keep asking, but let's say that it was a false solution. If we try to plug in anything, all 3 of those answers would be different, correct?
Well, there really wouldn't be anything to plug in. So, for example, like when we got here, 2 equals 6, our x value went away. So you don't know if you're plugging in 2 for x or 6 for x because there is no x.
Okay,
At this point, you would just stop.
okay.
If you went and you tried to plug in 2 for the equation and 6 for the equations, yeah, I believe you would get different answers for each one, and that should also tell you, okay, maybe I did something wrong here. Okay, so let's look at number 7. Okay, again on number 7, we're using substitution. So which equation would be the easiest to use, top or bottom? Top, and for what variable? Y. So we're going to get y by itself. So I'm going to have 2x plus y equals 5. The only step I got to do here is what? Yep, subtract 2x to the other side, and I get y is equal to negative 2x plus 5. Okay, so that means I'm plugging in that negative 2x plus 5 into what equation? The bottom, and for what variable? Y. Okay. Okay, so now we have 4x minus 2, and then for y, we're plugging in negative 2x plus 5, and then bringing down that equals 10. So what would be our first step now that we have an equation of all x? Distribute the 2 or the negative 2? Negative 2. So we have 4x, and what's negative 2 times negative 2x? 4x. And what's negative 2 times 5? Negative 10 equals 10. What are my like terms on my left side? 4x and 4x, which gives me 8x minus 10 equals 10. And then I'm going to add 10 to the other side, and I get 8x is equal to 20. And if I divide both sides by 8, I get x is equal to 20 over 8, but that can be reduced to what? 5 over 2? Good, because we're dividing both by 4, so 5 over 2. Or, I said it, but wrote the wrong thing. 5 over 2. Okay, so which equation do you want to plug in that 5 over 2? You want to plug it into the top? Okay. So we have 2 times 5 over 2, because that's our x value, plus y equals 5. What is 2 times 5 over 2? It would be 5, right? Because if we put 2 over 1, notice how there's a 2 on the top of this fraction and a 2 on the bottom of this fraction, so they can cancel. So we're left with 5 over 1, which is just 5. Or you can multiply across and get 2 times 5, which is 10. 1 times 2 is 2. 10 divided by 2 is 5. Either way, when you simplify those fractions, you get 5. Bring down my plus y equals 5. And once I subtract 5 over, I get y is equal to what? 0. So that means my solution crosses at what point? Correct. Okay. And then number 8 is going to be the last one we do for substitution. And then we're going to move on to the concept of elimination. So looking at both of these equations, which equation looks easiest to use? The top one. And for what variable? X. So x by itself. So we have x plus 3y equals 7. So what's the only thing we need to do here? Good. Subtract 3y, so we get x is equal to negative 3y plus 7. Where are we going to plug in that negative 3y plus 7? Bottom equation for what variable? X. So I have 2 times negative 3y plus 7, because that's my x value, plus 6y equals 14. So that means my first step here is to do what? Distribute. So I'll get negative 6y plus 14 plus 6y equals 14. So when I combine like terms here, what happens to my y's? Cancel. So I'm left with 14 equals 14, which is true or false? True. So what's my answer? Infinitely many solutions. So that means my graph would look like what? Line on top of another line. Good. Okay, so now we're going to look at substitution, because I have so many problems for elimination. Except we are going to look at, so I did the first 8 there, let's look at the last 8 here. 1, 2, yeah, I thought it was 2 separate notes, but I guess I combined it in one note. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if you have the notes printed, I'm looking at number 25. And this is now under elimination. So the reason I skipped the first 8 on elimination is that they're the exact same problems we did above, but we did it with substitution. So I'm just going to use fresh problems to show you elimination. Elimination. Okay, so with substitution, we had to get a variable by itself, okay? Then we had to plug in that variable into the other equation. For elimination, we are going to look at these equations and we are going to add them down. And the reason we're going to do that is when we add these equations down, one of the variables will end up canceling. So for example, in number 25, notice how we have a positive y and a negative y. So if I was to add these equations down, what would happen with the y's? They would cancel. Okay? So that means I already have x by itself once I'm adding down. Yes?
And the problems, will they always be in that the standard form?
No.
No, you would have to
Yeah.
put them back into the standard form.
Yeah. And they won't ever be this easy either. So in some problems we're going to do, we're going to have to manipulate the problems. So when we add it down, either the x's or y's cancel. But this is a easy example I'm showing first. So if I add them down, what is x plus 2x? 3x. We already said that our y's cancel out. And so we go straight to our equal sign. What's 4 plus 6? 10. So that means if we divide both sides by 3, we get x is equal to 10/3. So once we have our x value, just like we did in substitution, we plug it in for either equation. So it doesn't matter which one. Which equation do you want to plug it in for? Top or bottom? Top. Okay, so we have x plus y equals 4. Instead of x, we know x is 10/3 plus y equals 4. So in order to get y by itself, we're going to have to subtract that 10/3 over. So we get negative 10/3 plus 4. Okay? So we have to do what in order to get our answer? Common denominator. And what would that be? 3. So what would we have to do to that 4 over 1? Multiply top and bottom by 3. Okay, so that means we get y is equal to negative 10/3 plus 12/3. So that gives us the answer of what? 2 over 3. So that means this has one solution at what point? 10/3, comma 2/3. Good. Like I said, not all the problems are this easy where the y's and the x's or the x's could just cancel out. So let's look at now number 26. We'll see 26 is still an easy one. I don't want an easy one. That one too. I might skip around a bit then. Let's look at 23. Okay, notice here, if I start adding down my equations, neither variable is going to cancel. My x's won't cancel and my y's won't cancel. So that means I need to do something to one or both equations in order for either x or y to cancel. So when you're looking at these problems for elimination, you're first looking if you have a positive and a negative variable. Do we have that here?
Yes.
We have that with which variable? Y. We have a positive y and we have a negative 2y. So that means the only thing we need to do to this top equation in order for the y's to cancel out is to multiply everything by 2. Okay, so if we multiplied it by negative 1, we would just get a negative y and a negative 2y. So that if we added that, would get negative 3y. But if we multiply everything by 2, we'll have a positive 2y, which can cancel with a negative 2y. Okay, so that's what we're going to do first. We're going to multiply this entire equation by 2. Okay? Can't just manipulate the variable. You have to manipulate the equation. So that means for that top equation, we now have 4x plus 2y is equal to 10. And then I'm just going to rewrite that bottom equation under it. So 4x minus 2y equals 10. Then we add it down just like we did in the other problem. So now when we add this down, which variables are going to cancel? Y. And we're going to be left with 4x plus 4x, which is 8x, and then 10 plus 10. Okay. So then if I was to get x by itself, I would divide both sides by 8, and I get x is equal to 20 over 8, which reduces to 5 halves. You see how we did this problem already for substitution?
But why would you do it this way?
Why wouldn't you do it this way?
Would you?
Why would you? If on the test I say use elimination,
Oh.
use substitution. If I don't, yeah, so
Okay.
if I don't specify, you're using whatever makes the most sense, right?
Yeah.
So if you think this method is easiest, then you would use this method. But on the test, at least on this one coming up, I have to make sure you understand the difference between all three, right?
Yeah.
So there's at least going to be a question on graphing it, elimination, and substitution. On all the next tests coming up, I'm not going to care which method you use. Okay. So once we have our 5 halves, we have to plug it into an equation. It doesn't matter which one, so which one do you want to plug it into? Top. And remember, we have to use our original equations here. Okay, we're not using that equation where we multiplied by 2. So that's the difference between substitution and elimination. You're always using these original 2 equations, not the one we manipulated. Okay, so you guys said top one? Yeah. So we have 2x plus y equals 5. Instead of x, I'm going to be putting 5 halves. So 2 times 5 halves plus y equals 5. 2 times 5 halves gives us what number? 5. Good, because those cancel. So we have 5 plus y equals 5. That means my y value is going to be 0. So y equals 0. Again, see that this was the problem we did above, but we did the other method. So either method, including the graphing method, is always going to give you the same answer. Okay. Just trying to do 8 of these problems. We'll go ahead and let you guys attempt number 26 because it's one of those easier ones. So remember, this is by elimination, so you are adding the equations down because which variable is going to cancel right away? The y's. Okay, so I'll give you a moment to try that one. At least find me my x value. Okay, so for just finding the x value, you should have canceled out the y's, and you'd have 5x equals 9, which means we have x is equal to 9/5. Then we would plug in that 9/5 for either equation. I'm going to go ahead and plug it into the bottom one. So 2 times 9/5 plus y equals 2. That gives me 18/5 plus y equals 2. So I have y is equal to negative 18/5 plus 2. I would have to get a common denominator of 5. So I get y is equal to negative 18/5 plus 10/5. Which gives me y is equal to negative 8/5. So I have the point 9/5, comma negative 8/5. So on these type of problems, I think the hardest part is just going to be the fractions. Okay, any questions so far? Yes, sorry.
So, like, say they put it in like slope form, and one's in standard form. Could you do it in slope form?
So
Or does that
let me see if I have a problem like that. I don't. Well, let's look at 28. Let's say instead of this equation, this is, so negative y. Okay, so this is going to be y equals x minus 1, and then you have that top equation. Would it make sense to use elimination for this type of problem? No, you would use what? Substitution, because you already have a variable by itself. So most likely you're going to see these type of problems only with substitution. I'm not going to give you this and say use elimination. These would be one of the problems where I say use whatever method you like, solve the problem. And I would be looking for if you remember all these different ones and say, okay, this one already has a variable by itself, I'm going to use substitution. And then when I'm grading, I mean, if you use elimination, whatever, it's going to, and you get the correct answer, it's still right. But in my head, I'd be like, okay, this person knows that we should be using substitution. Okay. So for elimination, you won't see these type of problems that already have the variable solved. If you did, yeah, you would have to turn that y equals x minus 1 back into this standard form if you had to solve by elimination. So looking at number 28, which variable would be easiest to get rid of? X or y? So they're both equally just as easy to get rid of. Let's go ahead, instead of getting rid of y this time, we get rid of x. So we have a 2x and an x. So what would we have to do to which equation in order for these x's to cancel out? By 2 or negative 2? Negative 2, because we want them to cancel out. So that means we would have negative 2x plus 2y equals negative 2. And then I rewrite my top equation on top of the other one, because I'm going to be adding them down. Okay, so if I add them down, my x's do what? Cancel, and I'm left with 5y is equal to 5. So that means y is equal to 1. And which equation do you want to plug that into to find our x value? The bottom one, because that would be the easiest. So x minus y, bless you, equals 1. We have x minus 1 equals 1. So that tells us that our x is what number? 2. So that means this has one solution at what point? 2, 1. And yes, I agree. Elimination is so much easier than all three methods, in my opinion, too. So, like I said, just on this upcoming test is where I'm going to ask to see if you understand all three concepts. Okay. Let's go ahead and do one more problem. Let me find one that's not so... Okay, well, let's look at this one, because this one, even though it looks simple, something's going to happen here. What do you notice about the x and y variables? Everything will cancel. So that means 5x minus 5x becomes 0. It cancels. Negative 3y and positive 3y cancels and becomes 0. So we have 0 on this side. And then negative 11 plus negative 11 gives us 0. So we get 0 equals to 0,
True.
which is true. So this is what answer? Infinite solution. Infinitely, yep, many solutions. That's why elimination is a lot of people's favorite. Okay, what if we would have got a false statement? No solution. So we could have got a false statement.
So number 30 is one-sided.
Yeah.
Would essentially be the same thing.
Good, it would.
Multiply that by negative 2, right?
Correct. So if we multiplied this one by negative 2, we'd get negative 2x minus 4y equals negative 10. So if we were to add the equations down, again, what is happening to every single element?
So I'll cancel.
Cancel. So these cancel, this cancel, and this cancel. So 0 equals 0. True statement. Infinitely many. And again, there might come a time where you get 0 is equal to 5. False statement, no solutions. Okay. Trying to see if I can find one of those here. Negative 2. Well, even in this one too, what would be the answer to 32?
Would it have to be times, you multiply the top by 2?
By negative 2, right? Because we want them opposite signs. And this would also be one where we would get 0 equals 0. Infinitely many solutions. Notice how also these equations are similar because they are just a scalar of each other. So the first equation, if you multiply by 2, gives you the scalar of this second equation. That's another hint right there that it's going to be infinitely many solutions because we're going to have a graph with lines on top of each other.